Now let us learn lattices. Lattices definition here before that we learn upper bound. An element A belong to capital A is called, okay, A belong to capital A is called an upper bound of B, that is capital B, okay, upper bound of B if B is less than or equal to A, that is small b is less than or equal to small a. So we say an element A belong to capital A is called upper bound of capital B if B is less than or equal to A. That means for any element B, A will be the greater element. Okay, A will be always greater. So we say this A is the upper bound. Similarly, lower bound, an element A, element of A, that is small a, element of capital A. Small a, element of capital A is called a lower bound of B. Lower bound of B if A is less than or equal to B. If A is less than or equal to B. So here lower bound means this A will be always lesser than any element B. If A is lesser than or equal to, less than or equal to any element B, then this A is called as lower bound. Okay, lower bound of B. The next definition is, okay, now let us learn about the least upper bound and greatest lower bound. So what is least upper bound here? Least upper bound, an element A, element of A, that is small a, okay, an element small a is element of capital A. Okay, this is an element. An element small a is element of capital A is called a least upper bound. Is called a least upper bound of B. Okay, least upper bound of B. If for A, if A is an upper bound of B and A element of A dash. Okay, small a is less than or equal to A dash. Okay, here this small a is less than or equal to A dash. A is less than or equal to A dash whenever, okay, whenever A dash is an upper bound. A dash is an upper bound of B. So what we have to understand is, if A is an upper bound, if A is an upper bound, A will be always less than or equal to A dash, where A dash is also an upper bound. Okay, let A element of A, and this A is called as least upper bound of B. Okay, if A is an upper bound of B and A less than or equal to A dash, you see A is least upper bound. That means A is also upper bound. Okay, this A is also upper bound, and this A dash is also upper bound. That means A is an upper bound of B and A is always less than or equal to A dash whenever A dash is an upper bound of B. A dash is an upper bound, but A is less than. So this is called as least upper bound. A is less than or equal to A dash. A is less than or equal to A dash. So this A is called as least upper bound. Okay, this A is called as least upper bound. Now coming to the greatest lower bound. Coming to greatest lower bound, an element A, small a, okay, small a, element of capital A is called a greatest lower bound of B. Greatest lower bound of B if A is an lower bound of B and A dash is less than or equal to A whenever A is an lower bound. So here A dash is less than or equal to A. So what is that? A A is a lower bound. Okay, A dash is also a lower bound. A dash is also lower bound, but A dash is less than or equal to A, then this is called as, A dash is called as, A dash is less than or equal to A, so which is greater here? A is greater, so A can be taken as greatest lower bound. Okay, A dash is called as, sorry, A is called as greatest lower bound. So A is also a lower bound, A is also a lower bound, A dash is also a lower bound, but A is greater. Okay, that means A dash is less than or equal to A, so this A is called as greatest lower bound. Then we will continue with the lattices. Next definition. Definition of lattices. Definition of lattices. A lattice is a partially ordered set L, B in which every pair of element A, B in L has a greatest lower bound and a least upper bound in L. So lattices, in lattices we can take it as a partially ordered set in which every pair of element A, B in L. Okay, if you take any element A, B element of the set L, then it should have a greatest lower bound and a least upper bound in L. The set L should have a greatest lower bound and a least upper bound. Then we say that set is a lattice. Okay. Okay, now let us learn lattice homomorphism. Let L plus star, plus circle and star, and S, R and be two lattices. So here we have defined the operations like this. Okay, lattice with respect to the operation, you see here we have two operations and they are, this is plus and just a second, like this. Okay, L comma plus circle then star. So two operation it is defined in this set, and the next set is, you see this set is S comma R and, so we call it as R and, right? So here two set like this, they are lattices. Okay, they are lattices. And now we define here, what we define is, we define a map F from L to S is called a homomorphism if G A plus circle B is equal to G of A or G of B. Okay, so it is like G plus B is equal to G of A or G of B, and G of A star B is equal to G of A and G of B. So if it satisfies this, then we call it as lattice homomorphism. Then principle of duality. In a lattice L less than or equal to, if we replace R by and by R in any expression, the resulting expression is also true. So L and the operation here is less than or equal to, L comma less than or equal to is a lattice, and if you define R is replaced by and is replaced by R, then the resulting expression is also true. The resulting expression is called dual statement. So if you want to write the duality, you can replace R by and by R. And also here one more thing you can do, you can replace true by false. Okay, you can replace true by false and false by true. So that is called the duality principle, or the resulting expression is called as dual of the given statement. Okay, so that is duality. So now we will move on to the next thing, that is properties of lattices. Let L less than or equal to be a lattice, then the following properties hold. Idempotent property, A and A is equal to A or A is equal to A. Commutative property, A or B equal to B or A and B is equal to B and A. Associative property, A or B or C is equal to A or B or C. A and B and C is equal to A and B and C. Then absorption property A and A or B is equal to A or A and B is equal to A. Okay, now let us learn the meaning of A or B. Okay, meaning of A or B. A less than or equal to A or B and B less than or equal to A or B. A or B is the upper bound. Okay, so A will be less than A or B. A or B will be always greater. You see, B is also less than or equal to A or B. A or B is greater. A or B is called as upper bound of A and B. Also, now if you take another element C and A is less than or equal to C and B is less than or equal to C, then A or B is less than or equal to C, then A or B is called as least upper bound. Okay, therefore A or B is called as least upper bound. So meaning of A or B means A or B is the upper bound, also A or B is the least upper bound. That means whenever you have a here you see C is the upper bound because C is greater than A, C is greater than B. So C is upper bound of A or A and B. Okay, A or B is upper bound, C is upper bound of A or B, but here when you come, A or B is less than or equal to C. A or B is also upper bound, C is also upper bound, but A or B is lesser. Therefore, A or B is called as least upper bound. So you should learn this. Okay, in problems while proving theorems, we need this. So students, you can learn this. A less than or equal to A or B. B will be always less than or equal to A or B. Okay, because A or B is an upper bound. So you have to know A or B is an upper bound. That means A will be less than or equal to A or B. B will be less than or equal to A or B. Also, if there exists C such that A is less than or equal to C, B is less than or equal to C, then A or B is less than or equal to C. Therefore, A or B is the least upper bound. Meaning of A and B. Okay, A and B means A and B will be always less than or equal to A and B will be always less than or equal to B because A and B is the lower bound. Okay, A and B is the lower bound of A and B. So lower bound, you see, if C is less than or equal to A, C is less than or equal to B. That means C is a lower bound, but C is less than or equal to A and B. That means A and B is the greatest lower bound. A and B is the greatest lower bound. So you should able to understand this. We will be applying this in the problems. Okay, that means A and B less than or equal to A and B will be always less than or equal to B. So this you should learn. Also A and B is called as lower bound. Also if there exists C which is a lower bound of A and B, but this C will be less than or equal to A and B. Therefore A and B is the greatest lower bound. Okay. So you will learn the meaning of A or B and A and B. Okay. We will be applying this in the problems.